All right, so today I'm going to be reviewing some factoring things that you've seen before. One of them is greatest common factor, or GCF, and the other is difference of two squares. So with greatest common factor, just a reminder as to what we're doing. We're trying to divide something out of all of the terms in some polynomial. So for example, if you look here, we have 4x plus 10. Now, we want to see what we can divide out of both 4x and 10. Now, the answer to that is the greatest common factor, which is 2. So if we divide 2 out of 4, we're left with 2 and the x. And if we divide 10 by 2, we have 5. So we put our GCF on the outside, and then we have our parentheses and what we have left after we've divided. Now, what we're doing here is we're factoring, but we're really undoing the distributive property. So if we were to distribute this back through, we'd have 4x plus 10. And that's where we started. Okay, so we're doing the opposite of the distributive property here. We're undoing it. Now with this next one, we have 6x squared plus 3x. So if we start by looking at the numbers here, 6 and 3, we can divide both of those by 3. Now let's look at the x's. Both of these have x terms. The 6x squared, the x squared means we have two x's there. The 3x, there's no exponent, there's really an exponent of 1 there. That means we have 1x. So the biggest number that we can factor out is 1 because there's at least one x in each term. So that's how we get our GCF of 3x there. Now, when we divide out the x, we are really subtracting 1 from the exponent. So if we divide out the 3x, 6x squared divided by 3x, we get 2x plus 1. Now we factored out this whole 3x. But we need a placeholder of 1 because if we go to distribute that back through, we need something there to know that we would actually have something when we distribute it. Otherwise, if we didn't put anything there, it wouldn't show up again. So that wouldn't be true. All right, and this last one here, we have x to the third, y to the second, minus xy. So we have two different variables here. So if we look at the x's, we have at least one x in each term. So that's how we can factor out this x. And if we look at the y's, we have at least one y in each term. So that's how we can factor out the y. So that leaves us with x to the second, y minus 1 on the inside of our parentheses. Now remember, this x to the third is really x times x times x. When we factored out that 1x, we took it away. So we're only left with 2 x's, which gives us x to the second. That's how we get this there. All right, so if we look at GCF again here, we have 8, 16, and 16. So I'm going to see that I can factor out my 8 from all three terms, and I want to look at my variables. Now I only see x's in these two terms, so I know I can't factor out an x, but I do have y's in every term. But the biggest number of y's that I have in every term is just y to the first, or just y. All right, so 8 divided by 8 would give me 1, y to the 6th, we already took out 1, so we get y to the 5th, plus we have 16 divided by 8, so that gives us 2, y, because we took 1 away, x to the 3rd, and then plus 2, x to the 3rd, and we don't have a y there because we factored it out. So this would be your final answer here. All right, we're going to do the same thing on the next problem here. All right, now we want to look at our numbers again. We have -8, 4, and 20. So I know that I can factor 4. Whoops. I can factor a 4 out of each of these terms. So I'm going to put my 4 on the outside. Actually, before I do that, I should check if I can factor out any variables. And I can. I have an x in all of my terms, so I'm going to factor out that x as well. So I'm left with negative 2 x to the 5th y plus the 4 divided by 4 gives me 1, so x to the 2nd y to the 3rd plus 5. And again, we don't need to put the x because we factored that out. All right, so here we'd be doing the same thing. So we just have different numbers and letters. There we go. So I have 18, 18, and 60. So I can divide each of those numbers by 6. We also have p in all of these terms, and we have at least 3 of them in each of the terms. So I'm going to factor out p to the 3rd. And then we also have q in each of these terms as well. All right, so that would leave me with 3p to the 4th. We already factored out the q, r, plus 3p to the 1st, q to the 2nd, plus 10. All right, because we factored out this p to the 3rd, q, that's what we factored out over there. All right, and on this last one here, we're going to factor out a negative 3. Now, I know that I can factor out a negative 3 because each of these terms is negative. So I'm just going to take that negative 3 with me. All right, I also can factor out 5 of the y's, so y to the 5th. All right, so I'm left with 8yx to the 7th. Oops, so that's a 2. Plus, now that's positive because we just factored out that negative 5. We factored out our y's, so we're just left with x to the 2nd. And plus, we factored out that negative 3, y to the 2nd. All right, next we're going to talk about the difference of two squares. So this can kind of look confusing at first, but it's not too bad. What you are going to do is you're going to notice a pattern. So these take the form of a squared minus b squared. And our formula here that we're going to work with is right here. So what's going to end up happening is we're going to start with something like this x squared minus 4y, and we're going to end up with an answer that's 2 binomials. All right, and we're going to multiply them with each other. So this is basically the undoing of FOIL, as you guys probably remember it. So A, if we think of it this way, our A is what happens when we take the square root of that first term. And our B is what happens when we take the square root of that second term. Now, we're not going to worry about this minus in the middle. Normally, we'd keep that with the number right after it, but in this case, it's already factored in to the signs in our kind of our layout for our answer, so we don't need to worry about it. So if I took the square root of x squared, my A, the first term, would just be x. My B is what I get when I take the square root of the second term. So the square root of 4 is 2, and the square root of y squared is y. So those are my A and B, and now I'm just going to plug it in to my formula. So that would leave me with x plus 2y times x minus 2y. All right, there's another example right here, but we're going to do a few more. All right, so here I have labeled A and B. So A is what we would get when we take the square root of x squared, so we get x. And B is what we get when we take the square root of 36, or the second term, and we'd get 6. And again, remember, we don't worry about this sign in the middle. I know it goes against everything you've probably always been told with math, but it's already factored in to our symbols down here. All right, so we would end up with x minus 6 and x plus 6. Now, the order of these sets of parentheses don't matter because whichever way you multiply it, it's going to give you the same answer. So, and we can double check this by multiplying this out. So if I do my first, outside, inside, last, I'll get x squared plus 6x minus 6x minus 36. Now what happens when I combine my like terms is these two go away. They cancel each other out, leaving us just with x squared minus 36. And that's what we started with. It's a full circle. So, whoa. All right, so if we look at the second, come on. All right, there we go. Our A would be 1. Our B would be 3x. So I'm going to set up my parentheses. So I have 1 plus 3x and 1 minus 3x. Now notice the parentheses are right next to each other. There's no symbol in between, and this indicates that we're multiplying. All right, let's look here. So A equals 3x, all right, because we think about taking like the square root of that. B is 5. So I'd have 3x plus 5 times 3x minus 5. All right, and again, it's the same thing in each set of parentheses. We just have different symbols in the middle. All right, the last one here, our A is really B. And our B is 5. So I'm going to write it this way. B minus 5 times B plus 5. All right, doesn't matter. I put my minus sign first here, and I put my plus sign first here. Doesn't matter. All right, now let's look at this last problem here. And if you look at this, you'll notice that we have what looks like the difference of squares, but if you go to take like the square root of this, it doesn't come out pretty or a nice round number. It's not a perfect square. So this isn't the difference of squares, but what we can do is factor out a greatest common factor. So let's do that. So we can divide each of these terms. All right, we can factor out a 3 from both of them. Now what that does is that leaves us with 36x squared minus 1, because we need that placeholder. All right, so again, just because it looks like difference of squares, it might not be that. It might just be a greatest common factor. So like this one, we can factor out a 5, leaving us with 25x squared minus 49.